This is Algebra lesson 10.3. It is operations with radical expressions. Okay, let's talk about this here. What is 4x plus 3x minus x? Can anybody tell me what is 4x plus 3x minus x? It's what? It's 6x. Remember? That should be very simple to you. If I have 4 x's and I add 3 x's, that gives me 7 x's, and I take away an x, that gives me 6 x's, right? What about this? What if I have 4x plus 3y minus 2x? What do I do with this? What can I combine and what can I not combine? What's the rule? What is the rule here? You can only, if you're going to add or subtract, you can only add or subtract like terms. They have to be identical. So I can combine 4x and minus 2x, which is 2x. They're done. And then plus 3y. Does that make sense? You remember this? This is from like chapter 2, 1, last year, 6th grade, right? Okay, here's the deal. What if I have this 5 times the square root of 2 plus 7 times the square root of 2 minus 6 times the square root of 2? Here's the deal. I'm just going to tell you this. I'm not even going to show you why. I'm just going to, if it is a square root and you're adding and subtracting them, you treat them exactly the way you would treat them as if they were a variable. You can add and subtract them if they are like terms. So, if I have 5 square root of 2's and I add 7 square root of 2's, what's that going to give me? How many? No. 12, right? 5 square root of 2's plus 7 square root of 2's is 12 square root of 2's. Minus 6 square root of 2's? The answer is 6 times square root of 2. You treat it just like it was a variable. Does that make sense? No different than this. If I have 5 times the square root of 2 plus 3 times the square root of 5, I cannot add them. Why can't I add them? Because they're not like terms. So what they're going to start doing, though, is they're going to start going, okay, 5 times the square root of 2 plus 3 times the square root of 10, which you go, okay, hold on, let's look at this. What can I do? I can factor out 3 times the square root of 10, which would be, so 5 times the square root of 2 plus 3 times the square root of 5. Well, hold on, let me look here. I got to remember. What do I do? No, I'm serious. This is... Right. Oh, I remember. Okay. Let me give you one that they actually give. Let's do this. 2 times the square root of 18 plus 2 times the square root of 32 plus the square root of 72. Okay, so here we go. We're all looking? Here we go. This is what we're doing up here. This is long and weird. 2 times the square root of 18 is the same as... 18 is square root of 9 times the square root of 2. Agreed? Okay. And then this one here is square root of 16 times the square root of 2, right? And then this would be the square root of 9 times the square root of 8, which is the square root of 4 times the square root of 2. Now let's look at this. Okay, let's look at this. Do you agree that all I've done is I've taken the square roots and I've pulled them down, right? Okay, I'm going to put this in blue so that we don't get this confused, because that is it, and then that is it. Does that make sense? Oh, sorry, no. There. Now, what is that first term then? What you recognize the very exciting, there's something exciting here, and that is that square root of 9. What's that mean? 3. I'm going to pull out a 3. So this ends up being 2 times 3 times the square root of 2. Do you agree? Do you see it? Okay. Plus, do you see that very exciting number, square root of 16? Why is that exciting? Because it's just 4. So then it would be plus 2 times 4 times the square root of 2. And then, ooh, see that very exciting number and that very exciting number? That would be 3 times 2 is 6 plus 6 times the square root of 2. Does that make sense? Okay, so we have 6 times the square root of 2 plus 8 times the square root of 2 plus 6 times the square root of 2. Can you add these now together? Can you add them together? Why are you allowed to add them together? Because they're all times the square root of 2, like terms, right? Which would be 20 times the square root of 2. It didn't look like it was going to be that at the beginning. Do you agree? 2 times the square root of 18 plus 2 times the square root of 32 plus the square root of 72 does not look like it's going to end up being this clean. But it ended up being that way. You guys try one of those. Try this. Try 4 times the square root of 54 plus 2 times the square root of 24. Try that. Here's the deal. All you're going to do, let me just show you this, the process, is you're just going to take this thing by itself and factor it as best you can. Right? You're going to break it down as best you can. What do I mean by that? You're going to simplify that as best you can. And then you're going to simplify this as best you can. And then you're going to add it if you can. Let's take a look. 4 times the square root of 54. So 54 is square root of 9 and the square root of 6. Right? And this is the square root of 6 and the square root of 4. Right? Okay. What does this mean? That square root of 9, what can I do with that? Pull out a 3. So that guy becomes a 3. I now have 4 times 3 out here, right? I had the 4 originally. Don't forget that. Don't lose him. 4 times 3 times the square root of 6 plus, like him, 2 times this, not 2, 2 times 2 times the square root of 6, right? You don't lose him, and then he becomes a 2. So I have 12 times the square root of 6 plus 4 times the square root of 6. What's that become? 16 times the square root of 6. How many of you got that? 16 times the square root of 6. Does it make sense? Does it make sense? Okay. Try another one. Try another small one. 4 times the square root of 12 minus 6 times the square root of 48. Try that. All eyes are up here now. You're looking. This is, okay. You're just going to grab each one, right? And just simplify it. 4 times the square root of 12, that would be 4 times, leave the 4. Listen, if you need to, circle the 4 so you don't forget him, right? Because you don't want to forget about him. Okay, now we're going to have the square root of 4 times the square root of 3, right? Ooh, we like him. What does that become? That 4 becomes a 2, so I'm going to go 4 times 2 times the square root of 3. And out here, the 48 is square root of 8 and the square root of 6. And the square root of 8 is square root of 4 and the square root of 2. Okay? Which is, this is also square root of 2 times the square root of 3. Okay, so square root of 4 becomes a 2, so I have a 6 times a 2 out there. Those two square roots of 2 become another 2, gone, times the square root of 3. So here we go. 8 times the square root of 3 minus, 6 times 2 is 12, minus 24 times the square root of 3. What is 8 minus 24? Negative 16 times the square root of 3. How many of you got negative 16 times the square root of 3? That's not enough. Are you watching this, though? Listen, I don't care if you get it. Eventually you're going to care. Did you follow this? When I did this up here, were you paying attention? Anyway, whatever. When I do this, why do I do this? Why don't I just give you the answer? How come I just don't give you the answer? Why do I do this? So you could see the process. So you could see how to do it, right? So if you guys are going to tune out during that part, you're dumb. You're actually stupid. Don't tune out during that part. That's the part you need. Even if you think you got it. You should still watch, and that should reinforce what you already know, right? Do another one. I love it. So listen, this should not be difficult for you people, because this is 3 of those basic simple problems that I know you know how to do, just combined. Look. Can you guys simplify that for me? If I was just to ask you to simplify that for me over here, let's go 3 times the square root of 45. Can you simplify that? That would be square root of 9 times the square root of 5. This becomes a 3, so it's 3 times the square root of 5, which is 9 times the square root of 5. Yes? Oh, 9 times the square root of 5. Could you do the square root of 20 and just simplify that for me? Oh, let's do it over here. Square root of 20 is square root of 4 times the square root of 5, which is just 2 times the square root of 5. Oh, so this is 2 times the square root of 5, right? Could you guys do 245 for me? Yeah, you could. Let's do it over here. 245 is, do you know what it is? 5 and what? And what is it? 40, square root of 49. Oh, we love square root of 49, don't we? Yeah, that becomes 7 times the square root of 5. Oh, minus 7 times the square root of 5. Can I combine all those? Why? Like terms. 9 plus 2 is 11 minus 4 times the square root of 5. We're done. How many of you got 4 times the square root of 5? Good. Does it make sense? You just take each one individually, simplify it as best you can, and then add them or subtract them. It's that simple. Okay, the last part of this is not a difficult one. 3 times the square root of 2 times 2 times the square root of 6. Okay, you ready? This is no different than if I had 3x times 4y. What would I do here? Can you multiply them if they're not like terms? Think about it. Can you multiply them if they're not like terms? Yes. Okay, so what would I do here? What would 3x times 4y be? 12xy. You just 12 and then xy. You just do that, right? You just multiply everything. You just straight across. Well, what is 3 times 2? 6. Square root of 2 times square root of 6 is times square root of 12. Now here's the deal. That is true. It is 6 times square root of 12. What's the problem? It's not simplified, right? I can break this down to square root of 4 times square root of 3, which would be 6 times 2 times the square root of 3, which is 12 times the square root of 3. Does that make sense? You have to remember to simplify it, but it's just multiplying. Multiplying is easy. You just do it, and then you fix it. The other thing you might do is, if we go back to this original problem, it just depends. What is the other way of doing this if you wanted to? We did it the long way by just making it 6 times square root of 12. What could I do if I wanted to? I could simplify this and make this be 3 times square root of 2 times 2 times the square root of 2 times the square root of 3. Do you agree with that? What is square root of 2 times square root of 2? 2 times 2 times 3 times square root of 3, which is 12 times square root of 3. Does that make sense? You choose your method. I don't care. You guys try one. Try 2 times the square root of 6 times 7 times the square root of 3. Okay, you're watching. Here we go. All you do is just multiply. Looking up here. Your eyes up here now. What is 2 times 7? 14. Square root of 6 times square root of 3? Square root of 18. Obviously not done. That is now the square root of 9 and the square root of 2. Ooh, I love the square root of 9. That just becomes a 3. What is 14 times 3 times square root of 2? What's 14 times 3? 42 times the square root of 2. How many of you got 42 times square root of 2? Not difficult, right? Okay. Last one, this is the last thing you might have to do is this. What if I have 5 times the square root of 3 times 3 times the square root of 2 minus the square root of 3. Ooh, what is that? Now listen, it's ugly, but what are we looking at here? The distributive property. So, do it. Just do it. We're just going to distribute this. Rainbow, rainbow. What is 5 times the square root of 3 times 3 times the square root of 2? That is 15 times the square root of 6. Can that be broken down into something smaller? 15 times the square root of 6? No. I mean, it would be 15 times the square root of 3 times the square root of 2, which is still square root of 6. And then we go this times this, which is now a minus. What is 5 times the square root of 3 times negative square root of 3? Times, well, what is 5 times square root of 3 times square root of 3? What is square root of 3 times square root of 3? Square root of 9, which is 3 minus 15. Did anybody get that? Try this one then. Distribute it, please. You guys got it? Here we go.